Hello friends, welcome to AMT, Automotive Embedded Technologies. First of all, I would like to thank you each and everyone who is supporting me and subscribing to my YouTube channel as well as connecting me with Instagram and Facebook channels. And this gave me a lot of motivation to make much more knowledgeful videos towards future of automotive industry, I would say. And today I came up with an existing and an innovative technology of automotive sector, which is functional safety. There is an ISO standard for this functional safety. It's called IS 42662, the safety of the vehicles. And in this video, we will discuss more insights of this functional safety. What are the main aspects and how different kind of categories has been classified of this safety of these vehicles, and what are the concepts involved and how do we achieve. So let's go to overview. So first of all, we need to know what is functional safety and what is the importance of this in automotive. And then how do we achieve this functional safety in reality, in real vehicles, in real systems? And what is the role of system engineering in this? What is the role of software engineering in this? And what kind of different kind of safety methods and analysis methods we follow? And there is a kind of a reference V model for this. In V model from left to right, how this is followed a step by step and how this will help to achieve the functional safety in the product development. Also, we will know what is ASIL and what are different kind of factors used to determine these ASIL levels. Also, we know detailed classification of these ASIL levels. And also we know, we're going to know about typical ASIL classification of a vehicle issue. May not be single issue, but there are several issues, that are in vehicle has different kind of ASIL classifications. So let's go to the topic, first topic, and then we go more insights. So first of all, what is functional safety? So it's functional safety is a short term. It is also called as FUSA. This is a kind of a safety mechanism used to get safeguarded from various kind of hazards, life, health risks of the system users in real time. Maybe these hazards or risk scenarios occur due to a faulty system or an interrupted functionality of the system. As we discussed, there are several safety standards across different industries like automotive, medical, aerospace, etc. So the all standards main aim is to reduce or mitigate the risk of the hazard being caused from the hazardous situation. And the main goal and importance of the functional safety is to avoid such hazardous situations and overcome such undisturbed conditions from unknown faults from the system, sensors, actuators, different kind of electronics, harness, and environment. Also runtime system failures, maybe hardware or software failure. So for this, there are several standardized methods that should be followed in different levels of product development life cycle. Let's go to next slide. So how do we achieve functional safety in reality? So system engineering and software engineering are I would say, uh, the basic pillars that are involved to achieve functional safety whole product level. So let's go to each item in coming slides. So what is the role of system engineering in FUSA? So we have in system engineering several things about process, documentation, a certain kind of design analysis, and the concepts what we are going to implement in a system. So first of all, if you see hazard analysis and risk assessment, HARA. So this is a kind of method is used to determine different kind of hazards, unacceptable hazards and risks which may arise in the events of faults in the critical system during the usage of the system, kind of driving vehicle or driving car. So in stage of HARA, we do more study on the concepts and we define items out of the concepts to be implemented, and then we analyze the risk analysis out of these hazards, and then we rate these hazards in different kind of ASIL ratings. And coming to failure mode effective analysis, FMEA, this is a process which will be defined during the initial design stage of the system, and we can say this is a kind of a structured approach to discover different kind of potential failures that may occur, maybe detected during the design of the product or the process. I would say this is a it's a kind of a pre-procedures that what we follow from system engineering point of view. Coming to functional tree analysis, this is a kind of a also a method finding system failures and the relevant causes of these failures. So FTA and FMEA are similar, but FMEA talks more about in-depth study of and also approach of product design. Coming to next slide. So what is the basic role of software engineering in FUSA? So in software engineering, we have a lot of aspects of software development, configuration, integration, writing different kind of scripts for automation, and different kind of testing that we do for software are the major aspects here. Coming to the first major point, freedom from interference, and mainly described as it's a kind of an absence of several failures connected to each other when there will be a possibility of different safety violations during the data share between several components during maintaining the memory management during the storing of data in different memory segments or accessing data from different segments of the controller memory. Also the synchronized communication between different cores of the system. It might be synchronous or it might be asynchronous. Also, we must not have any corruption during the data access between different cores of the system. Nowadays, we can see that functional safety is not just part of software, also from hardware perspective. The hardware itself is coming from the hardware manufacturers supporting this freedom from interference concept. The manufacturer itself provide different independent memory segments to access and can be accessible across the cores defined by software systems, and then data can be shared in terms of accessing elements of basic software or application for different kind of real-time use cases. And the second one is unit testing and static analysis. Maybe couple of you may know already unit testing is nothing but testing of different kind of software components and providing code coverage for these components, like each line of the code must be executed during this unit testing. I mean, um, each corner of the or piece of software code must be able to access and must be able to executable with respect to the logics conditions like for loop, if loop, while loop, and different kind of logical methods that we follow in C programming or C++ programming. We must be able to reach each corner of the code to avoid dead codes. So there might be some major issues system level when there are certain kind of piece of codes are not able to enter and executable in real-time execution, and hence unexpectedly the system will get into a trap of this unexpected or dead code which is not used, and, and it will never come back for the normal execution, and then it will go to infinite loop, and sometimes it will lead to a software corruption, and hence system will not provide or produce good output for the user functions. Coming to static analysis, this is also a software test method, depends on MISRA C standard guidelines. These are several coding guidelines which are very much important to be followed during the development of the software. For example, the runnable names or function APIs, different kind of variables, pointers, structures, logical operators, left shift, right shift operators, and etc. So, like this provides a lot of coding guidelines that must be followed, must be adhered to avoid unknown software execution issues during runtime of the vehicles. So we use different data types, we use different shift operators, arithmetic operators, and so on. So there may be some unknown issues that may occur in real time where uh, we could have not noticed while implementing the software. So we must be able to see the more quality of the code which has been developed. Also, we have different kind of test and configuration of the tools is used in software development for testing of the components, for implementation, integration or configuration of the software runnables or application components or basic software components. Like there are several AutoSAR and adaptive AutoSAR configuration tools, and they also play a major role during the code generation. Since these are automatic code generation tools, must have also other different kind of coding standards. Let's go to next slide. In terms of process, I said functional safety process, like a way model. So here we can see the first item is HARA. Mainly it talks about hazard analysis and risk assessment as we spoke before. And here we can detect different kind of hazards from the concepts or items what has been defined from the basic requirements, and we perform risk analysis for these hazards. And then we assign different kind of ASIL categories of different requirements. And then for this risk analysis, that what we have done to mitigate, to avoid this risk from the hazard, we need to define a goal, a safety goal to mitigate this risk is called as definition of safety goals. And then From safety goals, we define these concepts into functional safety concept and technical safety concept. So functional safety concept has high level safety concept procedures, and technical safety concept are more detailed safety concepts, like derivation of different safety concepts from one functional safety concept. And then we go to software implementation. So during software implementation, we use several tools to configure different operating systems, different tasks, scheduling, time periods, different software components into different cores, startup behavior, booting, and so on. So we define several software configurable stuff during software implementation. And then we perform testing on the generated codes and our manually written codes. And then we club and we integrate. Then we perform this code coverage and static analysis, that what we discussed before. And then we go to testing of the safety test cases, what has been extracted from the safety concepts. And then we go to functional test to test our safety goals of the system. What has been defined from the risk analysis, the goals must be able to achieve, and hence the risk towards the hazard is mitigated. To ensure the risk towards an hazard is mitigated, we must perform different kind of testings and ensure that the goal has met. And this complete study over the each layer that we came across now, from left side of the V model to here, must be documented, must be reviewed from different kind of experts, and then provide safety cases to understand what are the items or concepts has been involved in the system, and what kind of hazards were determined, what are the risk analysis was done, what kind of ASIL categories they have been divided into, and what kind of goals are assigned to this to achieve, to mitigate the risk from hazard, and how the safety concept is derived. The safety concept is derived technical and functional safety concepts, and then how the software is implemented, how this is taken care during the implementation or configuration or integration part of software, and how the code coverage and static analysis and other component testing activities gone, and what kind of test cases were defined to achieve tests or at least test these safety concepts, and then did we achieve the goals what were defined before, and at the end did we really came out of the hazard situation, and then our safety goals are able to mitigate the risk. So we do the complete study and we make it as a safety case, and then we review. And then also there were several vehicle testing methods that has been involved in the industry to test different kind of safety conditions on road. I hope this is a basic FUSA process, I would say. Coming to next slide. What is ASIL and what are the factors involved in ASIL classification? So ASIL is a full form is Automotive Safety Integrity Level, and it's a kind of a risk classification that we just discussed before. And this is extracted and is defined by ISO 26262 standard for the functional safety of the road vehicles. So what factors determine an ASIL level? So there are three main factors, I would say. So one is severity, exposure, and controllability. So what is severity? Severity is kind of a potential severity of injuries caused by an hazardous event. For example, a vehicle is driving and there is a sudden brake, and there might be a chance that all the passengers and driver inside the vehicle got injured more, and maybe the vehicle position could have been changed when it is in high speed, and there might be severity of the injuries are high. There could be minor, there could be major as well. and and so this severity more talks about this kind of potentiality of the injuries caused by an hazardous event. Coming to exposure, how many times this may occur, how many scenarios there is a possibility to occur, frequency of several conditions, that again this hazardous event can reoccur, and eventually potential cause of these injuries can be high, is mainly considered under exposure. Coming to controllability, how much I would say time, or how much possibility is there that the driver could able to act and prevent this injury. For example, there is an unintended emergency braking during around 60 or 70 kilometers of the vehicle speed. The vehicle is running with a 60 or 70 kilometers per hour speed on road, and there is no object in the road, or no road users, I would say, and hence the road condition is good, and likely the driver can immediately act upon and react on this emergency braking, and then go ahead with certain speed. So this is kind of a controllability. The driver can control the vehicle easily. For example, there is an unintended acceleration, for example. So driver is going under 50 kilometer per hour, and there is emergency brake required, but it's not working. But still there is no hazard to the situation because we are under less speed. Maybe you can control the vehicle to get the vehicle speed to 30 kilometer per hour, 20 kilometer per hour without any hazard. So this more talks about controllability, I would say. So let's go to next slide. What are different kind of ASIL classifications? Here we can see severity, exposure, and controllability. This is the three dimensions we spoke about in before slide. So when we have light injuries, how the ASIL will be defined based on severe injuries, fatal injuries, and the exposure value and controllability. This is the basic table that we would follow. When coming to fatal injury, and the exposure is very high and controllability is very low, I mean it's very difficult to control, then we say this ASIL category is D. And coming to severe injuries, when the exposure is very low, also the difficult controllability is low, still we can say this is a QM because the exposure is very low and controllability may be difficult. Coming to light injuries, we have exposure low, but the controllability is difficult. Still, it is as LQM. Coming to exposure high for light injuries, but there is a difficulty for the controllability, then we define this as LA. So, likewise, this is a kind of a matrix generated towards severity, exposure level, and controllability situation. I hope you understand what is the basic ASIL classification. This derived from severity, exposure, and controllability levels. Let's go to next slide. So here we will talk about typical ASIL classification of vehicle ECUs. So there are several kind of vehicle ECUs, like electronic control units in car, like rear view camera, instrument cluster, airbag control unit, engine management, headlights, power steering, ADAS, anti-lock braking, and active suspension systems. So based on the failure, for example, rear view camera, there is no valid sensor data from rear view camera. Then we can define this as ASIL B because the exposure is high and there may be a chance that the car can hit the objects behind. When you come to airbag, unintended deployment of airbag can cause also deaths or severe injuries to the driver or the passenger, where this airbag works like a short explosion of a gas inside the airbag so that it comes on time and try to protect the user in real fatal accidents. But without accident, if there is a deployment of airbag, then also this will cause a lot of damage to the passenger or the driver. Coming to headlights, if you are driving in the midnight and there is no sunlight, and your both lights are failure, then there is a heavy traffic ahead. And hence we can say the exposure is high and it's difficult to control. Then we go to ASIL B category. So likewise, there are several ASIL categories defined for different kind of electronic control units in a vehicle. And this is not a standard or same for every car. This ASIL category will change between electronic control units based on the functions they deployed in car. So there might be other control units as well sitting in vehicle and deploying several jobs of the system, and hence the ASIL category will change, will not be same as it is. I hope you understand what are the basics of functional safety, how many types it is classified, importance of system and software engineering in functional safety. And at the end, thank you very much friends for watching this video. I would really appreciate that I receive some questions and comments on my video to understand better and to improvise the content of my videos, and this will really help me to do so. So at the end, knowledge is more reachable when you really like, share, subscribe, and stay connected friends with the YouTube channel Future of Automotive Industry. Also, I am available on Instagram. AMT Automotive Embedded Tech is a channel name, and as well Facebook. Thank you very much for watching this video, and bye.